Hello everyone. Today we'll solve this linear programming problem. We have to minimize z is equal to 20x1 plus 10x2 subjected to the constraints x1 plus 2x2 is less than or equal to 40, 3x1 plus x2 is greater than or equal to 30, and 40x1 plus 3x2 is greater than or equal to 60. x1 and x2 are both greater than or equal to 0. So we need to solve this problem using graphical method. To solve this problem, first we need to plot the lines on the graph. So let's take the first inequality. So we take it in the form of equation first. x1 plus 2x2 it is equal to 40. Okay. So we need to find at least 2 points so that we can plot this line on the graph. So we take x1, x2. Okay, so let's take x1 is equal to 0. When x1 is equal to 0, x2 is equal to 20. And when x2 is equal to 0, x1 is equal to 40. Okay, so we can solve this and we can find these 2 points. Okay, so we have got these points A and B. A is 0, 20 and B is 40, 0. Okay, so now what we can do, we can plot these 2 points on the graph. Okay, so let's say we have x1 and x2 axis, and then this is the point O, coordinates are 0, 0. Okay, so now let's plot the first point. It is 0, 20. So let's say, let's take this point, we call it 0, 20, and point is A. Okay, and we take, let's say, this is the point where, okay, so let's make it a little wider so that we don't face any problem later. Okay, so let's take this point here somewhere. Okay, this is 0, 20, and this is point A. Okay, and let's take this point here, 40, 0, and let's draw this line. Okay. Okay, so we have drawn this line. So now let's shade the feasible area also for this particular inequality. X1 plus 2x2 it is less than or equal to 40. Okay, so let's take the point 0, 0, and we see 0 plus 2 into 0 is 0, 0 is less than 40. Okay, so we can say that this portion of the plane where point 0, 0 lies satisfy our inequality, that is x1 plus 2x2 is less than or equal to 40. Okay, now let's take the second inequality, and let's first take it in the form of equation. 3x1 plus x2, it is equal to 30. Okay, so let's find the 2 points so that we can plot this line. x1 is equal to 0, x1 is equal to 0, x2 is equal to 30, then x2 is equal to 0, x1 is equal to 10. Okay, so let's take these points C and D. C has the coordinates 0, 30, and D has the coordinates 30, 10, 0. Okay, so let's put these points. Okay, so here we have 20, then we can take 30 somewhere here. Okay, so this is point C, which has coordinates 0, 30, and let's take point D. D has its coordinates, let's say 10. Here let's take 10, 0, and this is the point D. Okay, so let's join these 2 points and make the line. Okay, so this is the line. Okay, and actually I forgot to write B. So this is the point B, and this is the point A. Actually, this is the point A. Okay. Okay. So I think it is clear now. Okay, so next step, we need to find the region in which this point lies. Okay, so let's take the inequality. It is 3x1 plus x2. It is greater than equal to 30. Okay, so now let's put 0, 0 in this inequality, and 0, x1 plus 0 is greater than 30. Okay, so it says 0 is greater than 30. No, so 0 is not greater than 30. So our inequality is satisfied by that portion of the plane which lies above the line. Okay, on the right hand side of the line. Okay, so in this case our solution will be lying in upward direction like this. Okay, so we can shade this, and we can only take the values in the first quadrant because we have this non-negativity constraints. Okay, got it? So now, and these two lines also intersect here at this point. Okay, alright, so now let's take the third line. Okay, the third line is in the form of equations, it is 4x1 plus 3x2 is greater than equal to 60. Okay, so let's find the 2 points so that we may plot these two lines. Let's take x is equal to 0. When x is equal to 0, x1 is equal to 0, then x2 is equal to 20. When x2 is equal to 0, x1 is equal to 15. Okay, so let's put these 2 points, plot these 2 points. Okay, so we may call these points E and F. Okay, E has the coordinates 0, 20, and F has the coordinates, you may say 15, 0. Okay, so E is, you may say that it is the same point as A. Okay, so E is the same point as A, the coordinates 0, 20. Okay, so we call it A only. Okay, so let's don't call it this so that there is no confusion. Okay, so this is our point A with the coordinate 0, 20, and we have point F 15, 0. So let's take 15, 15 as somewhere here. Okay, and point F with coordinates 15, 0. Okay, so now let's join these 2 points. Okay, so we have joined these 2 points. Okay, so we have got this third line. Okay, so now we need to see whether the inequality holds or not. Okay, so whether the inequality holds or not, for that we need to, let's say, check 4x1 plus 3x2 is greater than equal to 60, and let's put the point, let's check for the point 0, 0. Okay, 0, 4x1, 4 into 0 plus 3 into 0 is 0, 0 is greater than equal to 60. No, it is not true. So again, our plane or portion of the plane that satisfy our inequality lies in the upward direction, in, let's say, in this direction in the plane. Okay. Okay, so now we need to see, and we also see that this green line and blue line, they intersect here. This is the point they intersect. Okay, so now we need to see that what is the region where the solutions are feasible. So we can see that, let's take some other color. Okay, so let me do purple. Okay, we can see here that this region, and let's call these 2 points where the lines are intersecting G and H. Okay, so we can see that this region, okay, which is covered by, this is actually covered by these, you may say, which is under these points, or which is surrounded by this region G, H, E and B. Okay, so this region, okay, it is common, or this is the feasible area. Okay, so this is the common area. Okay, so we can say that all the points which lie in this region G, H, E and B Actually, all these values, they satisfy our all three constraints. Okay, so our solutions lies there. So extreme point method says that the optimum value will lie on one of these extreme points. Okay, so we know the coordinates of E and B. Okay, so E is, or you can say, sorry, it is not E, it is actually the F coordinate. It is F. Okay, so this is not E, this is actually the F. Okay. Okay, this point 15, 0. So we are talking about. Okay, so this is not E, this is F. Our E was the same point as A. Okay, so we have this region. Okay, with 15, 0. Okay, so we know the coordinates of F and B. Okay, F is 15, 0 and B is 40, 0. But we don't know the coordinates of G and H. Okay, so to find out the coordinates of G and H, we need to solve the linear equations. Okay, so we need to find the point of intersections of these lines. Okay, so when to find the coordinates of point G, we need to find the point of intersection of this red line and the green line. Okay, okay. So how we'll do it? We'll do it by solving the linear equations. Okay, so that is, for the red line, equation is x1 plus 2x2, it is equal to 40, and for the green line, equation is 3x1 plus x2, it is equal to 30. Okay, when we solve these two linear equations, we get the point G. Coordinates of the point G are the coordinates. What are the coordinates that we will get here by solving it? It is 4, 18. Okay, and then we will find the coordinates of point H. How to find the coordinates of point H? For that, we need to find the intersection of the equations 3x1 plus x2, it is equal to 30, and our last equation 4x1 plus 3x2, it is equal to 60. Okay, and when we solve this, we got the coordinates of point H, which are 6, 12. Okay, so now we now know the coordinates of all the points. We know the coordinates of G. Coordinates of G are 4, 18. Coordinates of H is 6, 12. Coordinates of F, they are 15, 0, and coordinate of last point B, it is 40, 0. So now we need to put these values for x1 and x2 in the objective function. Okay, so what is the objective function we have? We have objective function as z is equal to 20 x1 plus 10 x2. Okay, so what will the value of z for the point G? It is 80 plus 180, it is equal to 260. For H, it is 120 plus 120, it is 240. And for F, 15 into 20 is 300. And for B, it is 40 into 20 is 800. Okay. And our objective function is we need to find the minimum value. And what is the minimum value out of this? The minimum value is 240. Okay. So you may say that this is our solution. The point H, at point H, we will be having the minimum value for the objective function. So we can write that this objective function will have the minimum value at the point H, where x1 it is equal to 6 and x2 it is equal to 12, and the minimum value of z it is equal to 240. Okay, so this is our solution for this linear programming problem.